Example 1. All right, so we've got 5x squared plus 1 in the denominator. Okay, so because we're just doing the example here, let's think about what's the derivative of 5x squared plus 1? What's the derivative of 5x squared plus 1? 10x. Okay. Well, we don't quite have 10x in the numerator, but we almost do. We have 2x. So how would we turn a 2x into a 10x? Okay, we can multiply it by 5. Are we allowed to multiply by 5? We can multiply by 5, but only if we also divide by 5. All right, so if we multiply by 5 and divide by 5, or if we multiply by, I'm going to rewrite the problem, if we have the integral of 2x over 5x squared plus 1 dx. If we multiply by 5 in the numerator, we'd also have to multiply by 5 in the denominator, right? But let's just go ahead and pull that 1/5 out of the integral. And so we have 1/5 times the integral of 10x over 5x squared plus 1 dx. Now notice we've got, going back to our chain rule up here, we're looking for u prime over u. Well, if we think of our denominator here as u, which you may not want to write over like that, but this would be u prime. So we have the integral of u prime over u, which according to this rule is the natural log of u. So we have 1/5 times the natural log of the absolute value of u, really, absolute value of u, which in this case is 5x squared plus 1. And this is an indefinite integral, which means we got to remember that whole plus c thing. Okay, so again, the general idea here is we're looking for some function in the denominator and its derivative in the numerator. Okay. So let's look at example 2. So some function in the denominator, so we have t. Now what would the derivative of t be? 1, which is there, but we also have this ln cubed thing, so that doesn't particularly help us, which means this is a different kind of problem. So first let's rewrite this problem as the integral. Now ln cubed of t, that may feel a little weird seeing that. That just means the ln of t quantity cubed. So ln of t cubed. And this is over t dt. Okay. Now we said the derivative of t was 1, and while the 1 is there, it doesn't help us explain away this ln of t, right? So we still have a problem there. So what's the derivative of ln of t? Well, if we think back to our notes here, ln of x would be 1 over x, so ln of t would be 1 over t. Okay. So, well, let's see here. Could we write this as the integral of ln of t cubed times 1 over t? Are those equivalent expressions? T? So having t in the denominator is the same as multiplying by 1 over t right here. And so now we've got u cubed times u prime. All right. So we want to integrate u cubed times u prime, or times du as we've seen it before as well, right? Then we can follow the power rule. It's just like the integral of x cubed dx. So what's the integral of x cubed dx? X to the 4th over 4. Well, u cubed times essentially du, right? Rather than saying u prime here, I'll say du. Follows the same rule. It'll become u to the 4th over 4. So in this case, our u is ln of t. And so this integral would be ln of t to the 4th over 4 plus c. Now think about the derivative of this expression really quick. If we did the derivative of this, we'd have to use a chain rule. All right, so we'd have 4 times ln of t to the 3rd over 4 times the derivative of ln of t, which we just said was 1 over t. All right, so we have 4 ln of t cubed over 4 times 1 over t. Well, the 4s would divide out. We'd have ln of t cubed times 1 over t. That is what we had right here. All right. So we can always, remember, anytime we're doing the indefinite integral, we can always check by taking the derivative. And many times that's just a mental math process. Any questions or concerns on these first two examples? You're not sure where I got a number or where something came from? Now's a really good time to ask. No? Good. All right, next example. Okay, so again, knowing the kind of problem here, we look at the denominator, we say, okay, what's the derivative of the denominator? What is the derivative of 1 minus e to the x? Well, the derivative of 1 is 0, right? So that's 0. We have minus e to the x. What's the derivative of e to the x? E to the x. In fact, let's go ahead and write down those two rules. The derivative of e to the u, where u is some function in terms of x, is equal to e to the u times u prime. So in this case, our u is actually x, and the derivative of x is 1. And so we just have minus e to the x. Okay, so rewriting this problem, I've got the integral from 2 to 3 of e to the x over 1 minus e to the x dx. Okay, now, do we have the derivative of the bottom right here? Is it exactly the same? Are these the exact same? No. What's wrong? What's missing? A negative. So am I allowed to just put a negative right there? No. But what can I do? Well, I can put a negative right there and a negative right there. That doesn't change anything, right? If I multiply by a negative and then multiply by another negative, it doesn't change anything. Right? So now we've got u in the denominator, right? And the derivative of u in the numerator, du or u prime. And so according to our rule, we have the integral of du over u is ln of u. So we have the negative still up front, natural log of 1 minus e to the x. And this is a definite integral. We're going from 2 to 3, so we have to have our bar, 2 to 3. And now we use the fundamental thermocalculus to evaluate this. So we have negative ln of 1 minus e cubed minus negative ln of 1 minus e squared. Absolutely. And so we pretty much evaluate that with the calculator. There's no easy simplification to be done here, no rules, nothing like that. And we end up getting negative 1.0943. But again, the general idea is we're looking for a function in the denominator and its derivative in the numerator. If you find that, then that means we can apply this new rule. If you don't find that, then that means it must be some other rule that you can use, like on example 2. Okay, now thinking about example 4, we have the integral of, well, actually, any question on example 3 before we move on? Any problems? Always looks easy when I do it, I know. Never any questions then. All right, example 4, tan x. So we're finding the integral of tangent of x. Now, if we think about that, that means we're looking for a function whose derivative is tangent of x. Right? So thinking through our trig rules, like the derivative of sine was cosine, right? Did we have any trig function that we took the derivative, we got just tangent of x by itself? Do we have any that had tangent of x at all in them? Which one gives us tangent of x as part of it? Okay, secant, what does secant give us? Secant x tan x, okay. But not just tangent of x, right? So there must be something else. There must be some other rule. Because, I mean, like the derivative of tangent is secant squared, right? But the integral of tangent isn't like secant squared, right? It doesn't work that way. So there's got to be another way to do this, and there is. Let's start by rewriting tangent of x. So how else could we write tangent of x? Sine of x over cosine of x. Let's try that. Okay. Now thinking about what we've been doing today, well, we now have a fraction, right? We have this quotient. So in the denominator we have cosine. So what is the derivative of cosine? The derivative cosine would be negative sine. Well, we're almost there, right? We have positive sine. So how do we make it negative? Multiply by a negative and by a negative. So now we've got u in the denominator and the derivative of u in the numerator. And so our rule says that's the natural log of u. Excuse me. So we have negative, because we've got this negative up front, natural log of the absolute value of u. So cosine of x. And this is an indefinite integral, so plus c. Which is why we didn't have a rule for the integral of tangent, because we hadn't done this yet. We have rules for certain trig functions, we hadn't done this yet. Okay, so look at the first assignment, or look at the first assignment problem. Okay. So what is the u here going to be? What do you think? 4 squared plus 1. So what is the du? 8x. So we don't quite have 8x. So we have to multiply by 8 and by 1/8. Right? So we'll have 1/8 times the integral of 8x over 4x squared plus 1. Right? Now again, and I don't know how you want to write this for yourself to remember, but remember that this is our u and this is our du. Once we get the integral of du over u, then we're almost done. There's no more real thought required. We keep whatever's in front of the integral, the 1/8, then we write natural log of u, which is the denominator. 4x squared plus 1, and then this is indefinite, so we have plus 6.